A very short demo of SonarG. SonarG is a big data solution for Guardium data. It focuses on two things. One is a very efficient data aggregation architecture where all the collectors send data to a single big data warehouse, thus removing the need for various aggregation layers and collapsing everything into one. And the second focus is on using best of breed big data technologies such as NoSQL and Hadoop and various others in order to do very efficient reporting, data aggregation, and providing access to Guardium data so that you can do all kinds of analytics, machine learning, etc. And so the first thing that happens is data from the collectors gets extracted in a very efficient way so that aggregation collectors are not loaded. And then that data moves over to the SonarG machine where a ETL process processes it and puts it into the big data warehouse. And then once there, you can access it directly from any type of programming language, SQL, NoSQL, R, various other statistical packages, all kinds of BI tools, etc. And I'll just give you a very short demo and a few examples of the way that you access data once it's in SonarG. So when you go to the SonarG system, it is a self-contained system. It has everything you need, both in terms of the ETL to process the Guardium data, but also in terms of various tooling for reporting and for analysis and analytics on the Guardium data. I'll just show you a few of these. So for example, if I wanted to view a report, I can use all kinds of predefined reports. So I will give a time frame that I want to look at the data. So I'm going to look at an arbitrary 10 days, and I'm going to look at all sessions, all Oracle sessions that I've accumulated from, in this case, a data set of 100 collectors. And so all I do is I fill in the parameters to the query that I want to run, and it produces a report for me. And in this case, it's going to go, it's a very large report because I gave it, data sets that, or parameters to the query that were very broad. So that's one example. Another example is a kind of a search and reporting type, a GUI where I can go in and explore the data, and so when I go into the system, the first thing that I have on the left is a faceted view of the top IPs and the top client host names and the top DB usernames, etc. All this data, by the way, is fabricated, so it's not in any way sensitive. So here's an example. I'm going to pick a certain time frame. It's a pretty broad time frame, and I'm going to look at, let me start with something simple. I want to see all the sessions that hit a certain host. So I pick the server IP and the time frame, and that's it. Right? So I run this, and it'll go into the big data warehouse and grab the data for me. So as you can see, it's pretty fast. I'm looking at all the sessions that have that hit a certain host, and then if I want to drill down and say, but I only want to look at things coming from this database user, for example, I just double click here, and then we run it. In this case, see all the sessions that go to this server from this username, and then I can see which clients it comes from, etc. And this is a relatively short query because I hit the session data set, and the session data set is relatively small, but I can do the same on a very large data set. So for example, you can see up here that there are 15 million sessions, but there are 16 billion full SQL records that may have come from an audit policy that had log full details. So if I want to query that data set, the 16 billion data set, all I have to do is, mark it that I want to see things from this data set. And then I run it. Okay, so now it's a far larger data set, but you can see the results are start coming back very quickly, even though it's a 16 billion size data set. And in the background, it may still be computing things, but it immediately gives me the first set of values. And then I can even do a very sophisticated query, like we can add a regular expression search. You can see here I have all the full SQLs that have to do with this. So I can add and say, show me everything that has 773. And if I run this, again, it'll still go against that 16 billion data set, but now it's a much heavier query because it's doing regular expression matching across things, but you can see it's still pretty fast. And so here I would expect in the full SQL to always see 773, 773, 773, but in a different place, right? So it's doing the regular expression match. So this is kind of the second example. And the third example I'll show you is I'm going to run something a little more, more on the analytics side, or less of a search type scenario, where what I'll do is I'll go in, and what I want to start counting is of all the failed queries, I want to look at how many client IPs it's coming from, and kind of see if there's any point in time in a year that I have more failures, or more failures coming from more client IPs. So maybe somebody managed to take over some kind of a host. So what I'll do is I'll pick the collection that I want. Collection is a data set, really, because I'm going to look at all the queries. Okay, so that's the instance data set. And then what this GUI allows me to do is kind of build these aggregation pipelines, which allow me to process the data, and it's very easy to learn, and you can do arbitrarily sophisticated analytics with it. So what I'll do here is, the first thing that I want to do is add a stage that's going to filter things, because what I want to do is only look at failures. So I'm going to say, where it's not equal to, and then I'll double click on failed SQL 0, because if it's 0, it means it's okay, it's not a failure. So I really want all the records that have some failure to them. And then what I want to do is I want to start grouping things. Okay, and what I want to group by is not really the period start. I want to group everything to a level of a day, a full day. So what I'll do is I'll double click on the period start, and here I will add an operator called day of year. Okay, which extracts the day in the year from the actual period, and then I'll do a count. Okay, just to know how many failures there are, but I don't just want to do a count. I also want to do an add distinct to set to array of the client IP. Right? So again, if I just run this now, just to see, it's not, I'm not finished yet, but I can run it and see kind of where things are at now, and whether the results are what I expect them to be. So I'm now running and doing this aggregation over 345 million records. Okay, and I get, per each day, like period start 1 is really day number 1. There have been 558 failures, and these are all the client IPs from which they came from, which, by the way, is in itself valuable. Like, I can take this and produce a report from it, and then I can deliver this report automatically to any target But in my case, what I want to do is I don't want the actual list. What I want is really to count them. Okay, so I'll add another stage, which is a projection stage, which is where I do my calculations. And I want to project, the day, so I double click that, and I want to project the count, so I double click that. But I also want to project kind of a function based on this now variable. So I'll call this clients, and I'll use another operator called $size. Okay, and when I'm done, if I run this, okay, what it'll do is it'll do the aggregation again, and every time it does this, it processes the 345 million, or if new data is coming in, then it'll process it at real time and update things for me. So now I have kind of, for every day how many failures there were and how many clients those failures came from. So I can see on day number 1, I had 558 failures, and they came from 150 sources. And day 7, I had about the same number, but it came from 191 clients. And I may want to give this a name, so this query will be saved for me. So I may call it GRD1. Okay, so clone pipeline and save it. And then once I have this, the other thing I can do is I can chart it. Okay, so I'll go into the charting. So there is a built-in visualization package, very dynamic, D3 type graphing. So I can remove things, add things, look at things. But in my case, what I want to do is create a new graph, not one that the system does for me. And I want to do a line with zoom, where the x-axis is going to be kind of the day of the year, and the y-axis is going to be the number of clients from which failures are coming from. So this is what I'm getting. So you see, it goes up and down, unclear whether, there's anything wrong, because, if I had one spike and everything else would be about the same, I would say, okay, there's something going on. But this just looks like, some days are good, some days are bad. What I can do is also give this thing a name and publish it. So now I can say, okay, call this GRD2. And then when I say publish it, it means that I can now send this or use this within any of my dashboards. So like if I take this, what I've really done when I said publish it is I've created a web service endpoint. And this web service endpoint can be used by any system. So if I have a dashboard and say I'm not even within the studio, but I have this link attached to my dashboard or to my other application, or I send it to someone by email, or or even I have another program that makes a call to this and wants the underlying data, then this web service is now open to the world. Whoever has access to it and whoever can authenticate to access it. And so this dashboard is now, can embed this graph that I just created based on kind of an analytic query that I ran on the Guardium data. So that's kind of a third type of access. And because the data can be accessed by, pretty much anything, because it follows the best and the most commonly used NoSQL paradigm, which is based on the MongoDB paradigm. Then, I can, for example, I can open things like R, which is a statistical package, and you can see I can download from CRAN a package called JSONR, and then I can make these calls into the system. And so, for example, I can look at failed SQLs and see what the median is and what the quartiles are, or I can do some, since R has packages for almost everything, including machine learning and outlier detection, I can get kind of a cross-section of all kinds of variables and have it discover all kinds of outliers for me. So that's the fourth type of access. And the fifth one, so even though the SonarG warehouse is a NoSQL big data warehouse, there still is a SQL layer. So I can definitely connect using the SQL layer, and I can, if I'm familiar with SQL, it's fine. I can use SonarG, which is the database where I'm housing all this data, and I can do a describe on the session table. Again, it's not a real table, but the interface gives it the appearance of a table, and I can then do something like select, I don't know, service, server type maybe, server type, comma count, star from session group by server type. Right, so any SQL person, can certainly have access to the data in the system. Get the breakdown of all the sessions and how many sessions belong to which database, etc. So thanks for joining, and this was a very brief demo of the capabilities, the data access capabilities within SonarG. SonarG is a big data solution custom built for Guardium data. If you want more information, more is available on our website, jsonar.com.